Hey guys, so today we're going to be learning how to use Pascal's triangle. So Pascal's triangle is used for binomial expansions, for binomials that have such a large exponent that it just ends up being so time consuming to distribute out. So for example, this would be like x plus 7 to the fourth. Distributing it out, you think it's simple, and it is, but it's so time consuming because first you have to distribute two of them between each other, and then because remember it's to the fourth, so you would have to do it 4 times, and this ends up being just so time consuming and it's easy to lose track of things. So this becomes x squared plus 14x plus 14, but then you have to distribute it to the next two. And like imagine if the exponent was like 8 or 9, you have to do it 8 or 9 times. So Pascal's triangle makes this so much more simple. It still is pretty time consuming sometimes, but it's not nearly as bad as it would be, especially with those large exponents. So how it's going to start, the triangle itself, first we're going to see what the triangle looks like itself. So it starts with a 1 at the top and then a 1 on either side to make like a triangle. From there, you're basically going to add the two numbers that are above it. So on the left of the 1 would be like a 0. Wait, let me get a different color. A 0 because there's nothing there, and same to the right of the other one, there's nothing there. So the next number that comes down there, 1 plus 0 equals 1. But then in the middle, you have a 1 plus 1. So that's going to equal 2. So a 2 is going to go underneath, and then 1, and then 1, and then 1 plus 2 equals 3. So a 3 is going to go in between there. You're making it a triangle, so you're filling in little window spots. Then 1 plus 3 equals 4, 3 plus 3 equals 6, 3 plus 1 equals 4, 4, and then there's 1. And then, yeah, so remember, there's just no 0 there. 1 plus 3 equals 4, 3 plus 3 equals 6, 3 plus 1 equals 4. Again, making sure you get this, you understand it. There's a clear 1 Pascal's triangle, but without having it beside you, you can make it yourself by adding like this. So we're doing a few more rows. So the row numbers actually, first of all, remember you're adding, not multiplying. As you go, you continue to just add the two numbers above it. We are not multiplying. It might be tempting to multiply. Do not multiply. You're adding the two numbers above it. Okay, so when it comes to row numbers, it actually starts at row 0. So the one with just a 1 at the top, that's row 0. Then the next one is row 1, then row 2, then row 3. Now you'll notice, like for example, row 4, 4 is the second to the ending sides of the row. And row 5, 5 is the second to the ending sides of the row. So that's an easy way to see it without having to go down like that. But it starts with row 0 at the top. Okay. So now we're going to do a problem using Pascal's triangle. So let's rewrite it again and keep it in the corner because you need to have it with you while you're solving. So once again, get in the habit of doing this. Okay, so we're keeping this in the corner while we do the problem. Okay, so now we're going to use Pascal's triangle to solve a binomial and expand it. So let's do x plus 1 to the fourth. So if you were to just distribute it out like that, it would end up being x plus 1, you're multiplying it 4 times, and then you have to distribute everything out. But we're not going to do that. We are not going to do that. We are going to use Pascal's triangle, and that's going to make it simpler and not more straightforward, but just less time consuming. That's the most important thing. So back to the row numbers. Remember, the first row is row 0. So look at your exponent. In your problem, it's x plus 1 to the 4th. So the 4th row is what we're going to use, and these are our coefficients. These are the coefficients. And remember, starting with row 0, then in row 4, since the exponent is 4, we're using the 4th row. This is a really important thing to remember. Pascal's triangle gives you the coefficients. So these are the coefficients we're going to use. So now write out the coefficients. So 1, 4, 6, 4, 1. Now, starting with the first part of the binomial. So the first part of the binomial, that's x. That's going to go by the first coefficient, and you're going to use the exponent. So x to the 4th, because that's the exponent that we have. Now, each one from here is going to be minus 1 from that exponent. So the next number is going to have x to the 3rd. The one after that is going to have x squared. The next one is just going to have x to the 1, which is just x. And then the last one will be blank. There will be no of the first part, no x. So now the second part of the binomial, that's the 1. It's just positive 1, so you don't worry about that. But it's going to start backwards. You're going to start at the end. It starts the opposite way. So you're going to do 1 to, again, not the coefficient, the exponent is 4, so 1 to the 4th. Then 1 to the 3rd, it's minus 1 each time. 1 squared. And then just 1. And then the last one, or the first one, is blank, no 1. Then there's a plus sign between all of these clusters, all of these expressions. It makes one big expression. And then you're just going to solve. You're just going to simplify this. Multiply everything out. So the first one is x to the 4th. The next one is just 4x cubed, because there's just a 1 there. Next one is 6x squared, because 1 squared is just 1, so it's just times 1. 1 cubed is just 1, so that's just 4x times 1, which is just 4x. And then 1 to the 4th is just 1. So that is our answer, and you did it. So if you had done it the other way, where you just distribute out the x plus 1 4 times, it would have given you this exact answer. Either way, you would have gotten this answer, but that would have taken even longer than this. So that is how you use Pascal's triangle to simplify and expand binomials.